All right, so this is our second problem. Here, let's make sure. Okay, so let's read the problem. So it says an object is found within our solar system, in our solar system, to be orbiting the sun. Its period is 752.6 days. How uh, how far is the object from the sun? All right, so this is we're going to do this first in what are called astronomical units. One astronomical unit is the average distance between the Earth and the Sun. In miles, it's about we don't usually use miles, but it's about 92 million miles. All right, so that's just to let you know. Um, all right, so let's go ahead and do. All right, so I've written the conversion between astronomical units and kilometers. So one astronomical unit, the again, that's the average distance between the Earth and the Sun, because the Earth gets a little further from the Sun, it gets a little closer from the Sun, but the average distance is what's called one astronomical unit. And um, 400 years ago, during the time of Johann Kepler, whose formula we're about to use, they didn't know how close the Earth was to the Sun. So we actually had to use, or well, Kepler had to use um, what are called astronomical units. Now he was able to figure out how far away the planets are from the Sun by discovering his third law of planetary motion. All right, so that's what we're about to use. And then when we use that, then we'll do the conversion between astronomical units and kilometers, which of course we know that value now. We know this quite well. There it is. All right, so 150. The way I always remember it, it's 150 million kilometers. All right, so that's also 92 million miles. Just we don't normally in this class deal with miles, but that's what it is. All right, so Kepler discovered that the following mathematical relationship between the orbital motion of planets, that that the period, and it took him a long time to figure this out, but he eventually did. The period squared is proportional to the average distance that the planet is from the sun cubed. All right, and now we have an equation. Okay, so this is um, you know, the what as soon as you ever have an equation in any science course, you have to know what the proper units are. The version that that we're using right here, this is Kepler's original third law. The period has to be so here. I'll just indicate that over here. The period must be in years, and a has to be in astronomical units, all right, in AUs. Now notice they. So what we're going to have to do, we're going to have to do what's very typical in science, in all the sciences, not just the physical sciences. They gave us the period of this object, whatever it is. This object is moving around the sun, but they gave us the period in days. All right, and so if I know the number of days in a year, I can do a conversion. So let me write that down. Okay, so here's another conversion. This is separate. So I know that in 1 year there are 365.24. Right, so you know days. Don't forget the 0.24. That's really important. So 1 year is 365.24. All right. So now we're in a position that we can do a conversion, right? And then once we convert the period into years, we will be able to plug it into this equation, and we'll plug it in right here, um, and we'll figure out the distance in astronomical units. All right, so the period is given to us as 752.6 days and we know that that's days. We know that in 1 year, so you got to cancel the units here. So in 1 year, there are 365.24 days. All right, and so the days will cancel. All right, and so all I have to do is multiply those two numbers. I'm going to do that right now. Let's see, did I open up my calculator? I think I did. Let's see, that's off the screen. All right, so I'll just put it right here. All right, so 365.24 times oops, not time. One thing I'll just say times one because that doesn't change it. Geez, I messed it up already. So it's 752.6 divided by, okay, that's right, 365.24. All right, so that will give us the number of years. All right, and so it turns out that it's 2.06 years. All right, so we're going to use that. So 2.06 years. And why did I round it to that? Notice in the problem, and this is going to be true for the Part B tests as well. I'll always tell you how many units to round it by. And but by the way, when you're doing this on Blackboard, um, you just put in the number, right? So you don't put the unit, like it'll ask you, what, like for example, for part A here it says, what is the distance in AU? All right, so we're going to figure that out, using this 2.06. All right, so here, let's get some room here. All right, and there's so this is just continuing the problem. I just got us a little bit more room. So we're going to use this period, which we just determined by figuring out the number of days. Sorry, the number of years in 700 and something days. All right. Anyhow, so this is the full number, of course. That's the calculator answer. And so if I square that, that's going to be what a cubed is equal to. Okay, so I'm going to square it. All right, so that this number right here is what a cubed is equal to. Now I have to. So now to figure out what a is the distance in astronomical units. Okay, so that's what a is. And to figure that out, I have to take the cube root of both sides. All right, so I'm taking the cube root of whatever this number is. Like, okay, so I'm just going to leave it in my calculator, but 4.245 or something like that. 4.2459. I'll just write that. 4.2459. All right, so I'm taking the cube root of that. All right, so now depending on what kind of calculator you have, some calculators you can directly take the cube root. With this calculator, it's a little bit more complicated. There's no cube root button. See, there's a square root button right there for this particular thing. So here's what I'm going to have to do, just to remind you. All right, so you probably remember this, or maybe you forgot it. When you take the cube root of something, you're raising it. Like the square root, for example, is raising it to the 1/2 power. To take the cube root of something, so that something here, of course, is 4.2459. All right, now let me say this as well. This number is a rounded number right here. I'm going to leave it unrounded in the calculator, and then and use the unrounded version in the calculator. So all I have to do is raise that to the 1/3 power. That's what the cube root means. All right, so that's all I have to do. All right, but there's a special way of doing that. And let me show you that. All right, so raising something to the power, you say x to the y. All right, this number is already in my calculator, so I'm going to um, I'm going to raise that. Let's see. So, oh, actually, you know what I'm going to do? Just to make sure I don't mess up, I'm going to store that. All right. So that's, see that number. Watch, if I clear it and I hit memory store. Oh shoot, memory recall. Well, I already messed up. All right. Here, let me pause it and get that number back. All right. So I think I stored it properly. Let's take a look here. Um, that's okay. So if I hit memory recall, yeah, okay. So that's the number. All right. So I've got to take the cube root of that. So if I hit this y to the x button, so that's just this calculator. This is particular to this calculator. Um, you might already have a cube root button, and that's perfectly fine. But you have to know how to do this. All right. So I hit this. So it says to see there's a little caret key, and so it says raise it to what power. Now, if I hit 1 divided by 3, the problem with that is a repeating decimal. As you probably know, that's a repeating decimal, and that won't give you the proper answer. So what I have to do is raise it to the 1/3, but open parentheses. So it's got to be exact, right? So open parentheses, 1 divided by 3, and then close parentheses. And remember, the only reason that I'm doing that is because 3, it's a repeating decimal. So the parentheses make it exactly raised to the 1/3 power. All right, so let's see what that turns out to be. So this is what A is going to be. All right, so A is, so if we round it to 2 places past the decimal, notice it's 1.6, so it's 1.61, but then if I'm rounding it to 2 places past the decimal, the third place is a 9, which is greater than 5, so I round it up. All right, so the answer to part A, right, the answer to part A of my problem here is 1.62. All right, so 1.62 astronomical units. And I know that in 1 astronomical unit, right, so 1 AU is, 150 times 10 to the 6. I'm going to just use the E button, right, the E6. All right, so that's just another way of writing times 10 to the 6th kilometers. All right, so the AU's cancel. So all I have to do is take what's in my calculator and multiply it by 150 million, and that'll give me the answer, the part B answer. All right, so let's do that. Here's my calculator. All right, so it's already, there's the number, and all I have to do is say times 150. All right, so you have to know how to do this in your calculator. Remember, with exponential notation or scientific notation, you use this EXP button, or on a lot of calculators, it has an EE button. So it's like two capital E's. All right, so I'm hitting EXP, so that's to the 6th power. So it's that right there is 150 times 10 to the 6th. So I'm multiplying 1.62. Well, there's the unrounded version, and multiplying that out, and then my final answer is there. There it is. All right. So the final answer is normally you're going to want this to be in scientific notation. Okay. So so let's see where my decimal is. All right. See, there's my decimal between the 0 and the 6 and the 6.9 right there. All right. So if I move the decimal, right, the commas show you're moving it 3 places. So 1, 2, 3, 1, 2, 3, 1, 2. So it's 2.42. All right. I'm sorry, 2.43 times 10 to the 8th. All right. So that's the final answer. All right. And this is what you would type into Blackboard, right? 2.43 times 10 to the 8th.